Okay, welcome back. We had played a little bit of Sequence Detective in the last video and tried to figure out if the sequences were arithmetic or not. We're going to start by doing a very similar thing, except now we have some formulas that we're trying to figure out if they're arithmetic or not. And so this one, this a sub n is 2 plus 3 times n. We're wondering, is this arithmetic? Okay, and remember, arithmetic is basically the same as linear. So I'm really just asking, is this linear, right? Is this like mx plus b, or is it the form that we had given before, the standard form for our arithmetic sequences was, if you remember, it was like d times n minus 1 plus a, where d was the common difference, a was the first term, and then you threw in this minus 1 because sequences start at 1, not at 0. Okay? And so this is an arithmetic sequence because it's linear. Okay? But it's not written in this form like we had seen before. So I'll show you how to write this sequence in this form, but let's first just acknowledge this is a linear function. If you would replace this with x and this with y, right, it would graph out a straight line, right? So this, yes, this is linear. And it's our word for that in sequence notation is arithmetic, okay? What about this one? The a sub n equals 2 plus 7 to the n. If you replace n with x in this equation, is that going to be linear? Well, no, the variable is in the exponent, right? And so this would kind of be like an exponential almost, but and we'll talk more about when n is in the exponent in our next lesson. But no, this is not arithmetic. Okay. So we just played our sequence detective again, and we figured out whether these equations represented arithmetic sequences. And to figure this out, you could list out some terms in the sequence as well and just see if they are going up by the same amount. But you can just see by looking at the equation, okay? So now what I do want to do is on the homework, it's going to ask you, like, are these arithmetic? And if they are, they'll want you to write it in this standard form, okay? Where instead of having just an n here, we want to have an n minus 1, okay? So what I'm going to do is my an is, well, 3. I'm still gonna have 3 times n, but I want to have there be an n minus 1 with the n, right? So I'm gonna throw that in. Okay, so I'm adding in the n minus 1 to be in there so that I get it to look more like this. Okay, but I added that minus 1 in there. It wasn't there before, right? And I also had this plus 2 from before, right, for this sequence. Okay. Now this is almost similar to completing the square in that we added something to this equation that wasn't there before. So I'm going to need to cancel it out so that I didn't actually change anything, right? So what did I do? Well, there's a 3 in front of the parentheses, so I didn't just subtract 1 here. Well, I mean, I did inside of the parentheses, but for the whole equation, what I've really done is when I distribute that 3 through, I will have subtracted 3 from the whole equation. So to compensate, I'm going to have to add 3 so that I get the same thing. Okay? And so my standard form for the equation is 3 times n minus 1 and then plus 5. Okay? So 3 is the common difference, right? It's the slope of your line. You could kind of think of it like that. And 5 is the first term of your sequence, right? When you plug in n equals 1 into this, what do you get? You get 2 plus 3 is 5, right? So that's the first term of your sequence, okay? So this would be how you would write it in our kind of standard form for arithmetic sequences, which is this, okay? This is d times n minus 1 plus a. You will need to know the standard form for the test. They won't give you any formulas about sequences as you're doing it, so you will need to know this formula. But essentially it's just y equals mx plus b just shifted to the right one, okay? So one last thing I want to mention before this video is over, and I let you kind of work on the homework, is I want to do one more example problem that's a little bit different from these ones we just did, but it's kind of along the same vein. Let's say that I have a sequence here, 4, 10, 16, 22, and so on, and we'll say that it tells us that it's arithmetic. We want to find the common difference and the nth term of this. So find d, the common difference, and the nth term, a formula for the nth term, okay? So the common difference of this sequence is how much it's going up and down every time, right? So like from 4 to 10, we're adding 6. From 10 to 16, we're also adding 6, right? And then from 16 to 22, we're adding 6. So the common difference here, d, is 6 for this problem, right? For this sequence. Okay? So then what's the formula going to be for the nth term? Well, we just use our standard form of our equation. A sub n would be d times n minus 1 plus a, right? So a sub n is d. So d in our problem is 6 times n minus 1, and then plus a. And if you remember, a is the first term of your sequence. So in this case, it's just 4. So this would be our formula for the terms of this sequence. Okay, so hopefully that kind of helps you get a better idea of what's going on with arithmetic sequences. There's a few more practice things we're going to do with them, finding equations for them, and eventually we're going to switch into finding the sequence of partial sums of these arithmetic sequences. So we'll kind of head towards that soon.